particle moves with simple harmonic motion of amplitude 0.75 meters. The period of the motion is 4 seconds. The first question, we want to find the maximum speed of the particle. Well, previously we saw that the particle obeys this formula here, the position, a sinusoidal function. We could use either sine or cos. Omega is root k over m. So k is some constant. If we're talking about a spring, k would be the spring constant. M is the mass of the particle. To get the velocity, we just differentiate this with respect to time. We saw this before as well. We also saw that the maximum speed is given by omega times a, because the cos function lies between -1 and +1, which means that v lies between minus omega a and plus omega a. So the maximum speed is just the magnitude of omega a, because we want the speed to come out to be positive quantity. That's why we get the magnitude. We also know that the period, that is the time taken for one oscillation, is 2 pi divided by omega, and we're given that the period is 4 seconds. So that means that omega must be 2 pi divided by 4. So we know what omega is now, and we also know the amplitude a. The amplitude is 0.75 meters. So we just have to get the magnitude of 2 pi over 4 multiplied by 0.75. Well, this is going to be positive anyway. So the maximum speed is 3 pi over 8 meters per second, because the amplitude is in meters and time is in seconds. Find the time taken by the particle to move from the position of maximum speed to a position at which its speed is half its maximum value. So the maximum speed is 3 pi over 8. So we could start by getting the time taken to reach this maximum speed. So we put v equal to 3 pi over 8. So what is v? Of course, v is given by this formula here. Omega a, we have established is 3 pi over 8. We normally take this to be positive, but it doesn't matter. We could actually have it negative as well, because we're getting the magnitudes of these to get the speed. Anyway, it doesn't matter whether you make it plus 3 pi over 8 or minus 3 pi over 8. So we see now that this here must equal 1. So we want the cos of pi over 2t plus phi to equal plus 1. That means that pi over 2t plus phi equals the inverse cos of 1, which is 0. So here we get the time at which the speed is 3 pi over 8. It's minus 2 phi over pi. Now we could set phi equal to anything we like, but I will leave it as it is. I mean, we could have set phi equal to 0 actually. It doesn't affect this motion. It doesn't affect the speed or amplitude of the particle. But I think I'll just leave it like this. You'll see that the phi will cancel out at the end. Now we are interested in the time for which the speed is half the maximum speed. Well, the maximum speed is 3 pi over 8. If we get half of 3 pi over 8, we get 3 pi over 16. So we need to solve this to find out what t is. So we divide across by 3 pi over 8. So 3 pi over 16 divided by 3 pi over 8 is a half, because this here is half of the maximum velocity. To get the argument of this cos function, we get the inverse cos of a half. The smallest value for the inverse cos of a half is pi over 3, or 60 degrees, but we want to have this in radians. So then we solve for t. We bring the phi over and divide across by pi over 2. Pi over 3 divided by pi over 2 is actually 2/3, and we have the phi divided, the minus phi divided by pi over 2 gives us minus 2 phi over pi. So this is the time for when the particle is at its maximum speed, and this is the time for when the particle is traveling with half its maximum speed. So we just want to subtract these two times. So I take one of these times and subtract the other one, and you can see that the terms involving phi cancel out. So I could have set phi equal to anything I like. I could actually have set phi equal to 0. And then at t equals 0, the particle is traveling with maximum speed. And if phi was 0, then at t equals 2/3, the particle is traveling with half its maximum speed. Of course, if we subtracted the other way around, we would get minus 2/3 seconds. But of course, we want time to be positive, so we get the magnitude of the difference between these to get plus 2/3 seconds. Here is a graph of v against t. Now I've set phi equal to 0 here to make the graph easier to draw. So if we put phi equal to 0, we have v equals 3 pi over 8 times the cos of pi over 2 times t. So when t is 0, we have 3 pi eighths times the cos of 0, or 3 pi over 8 times 1. The cos of 0 is 1. So the amplitude is the value of the function at t equals 0 when we set phi equal to 0. So the range of the function is from minus 3 pi over 8 to plus 3 pi over 8. Now, we want to find the time for which the speed is half the maximum speed. So we get half of 3 pi over 8, which is 3 pi over 16. So we go halfways along here between 0 and this value. And if we project down, we get a value of t, which is 2/3. So this is the time taken for the speed to go from its maximum value to half its maximum value is 2/3. We just have to be careful. Well, we didn't really have to be careful here, but that we don't end up getting this time here. At this time here, the speed is also 3 pi over 16. So when we were solving these equations, when we were getting, say, the inverse cos of 1, that we have 0, because that's the smallest value for the inverse cos of 1. Another value for the inverse cos of 1 is pi radians, or 180 degrees. So if we'd used pi, we would end up getting, say, this value here for t. So when we were solving these equations, we needed to take the inverse cos. In the other equation, we had to get the inverse cos of a half. The smallest value for that is pi over 3. But there is another value. So we're taking the smallest values when we're getting inverse cos. That ensures that we get this value, not this one here, or this one here, and so on.